I'm very pleased to get to announce our next session. This session is on leaf removal. In cool climate grape growing especially, leaf removal plays a critical role in final fruit quality. Today, you will hear from Dr. Pony and Dr. Patty Skinkis, and hopefully be able to take some of their ideas and data out into your vineyards and put them to practice. Dr. Stefano Pony is a professor at the Catholic University in Piacenza, Italy. He is a professor of viticulture and is a past chair of the Department of Sustainable Crop Production. He is the director of the International Master Venet, Viticulture and Enology, where innovation meets tradition. He has been widely published in international peer-reviewed journals. He has spoken around the world and been awarded multiple prizes for his work in viticulture. His papers on leaf removal are some of the most creative and instructional that I have read on the subject, and I'm beyond thrilled to have him here to speak with us today.
Hello, my name is Stefano Poni from Cattolica University in Piacenza. And first of all, I would like to thank the organizer for this online invitation. That is the only thing we can do, of course. And the title of this presentation, as you can see, is Early Leaf Removal, Why, When, and How. So basically, before actually getting into the topic, I would like to give you a very brief summary of the area where we are working. We are in the Colli Piacentini area that is located here, well, close to the Po Valley. This is the Po River, as you can see. And the green area is the area where all the vineyards are located. So we grow approximately 6,000 hectares of vineyards, and we have four main varieties, Barbera and Curatina for reds, and Malvasia and Ortrugo for whites. So apparently, we have the largest river in Italy here, and so we are basically in the north of Italy, so we should not be suffering of any drought. Unfortunately, this is not the case. As you can see here, this is just a view of some vineyards or clusters or bunches that we took 2 years ago. And you see that fortunately we do have very severe drought in summer. This is the main river crossing the town that is totally dry, as you can see. And so this is just to say that we are also facing this kind of issues. And I will actually relate this also to the leaf removal practice in a minute. Well, again, just to give you an idea of what is the weather variability in our area. This is just a picture of a Nugly vineyard that was taken year 2002, where you see there is a lot of downy mildew here. We were not able, actually, they were not able to control the disease. And you saw that there was some, natural defoliation due to this very severe damage. But look at the same vineyard the year after. So the 203 season, that has been recorded as one of the driest years over the last 4 centuries. And you say that it seems really a different region or a different area. Well, basically it's the same vineyard. I would say almost the same row. So that gives you an idea of what is the variability of the climate. And so for this reason, what we need to do here is also being able to adjust intensity and timing of summer pruning operations. Again, just to finish my brief introduction, this climate change is also, causing, for instance, 3 years ago, very severe frost damage in the Prosecco area. Not very surprising because, we got a very early bud break. And so at that point, chances to run into a low temperature regime is very high. And actually this was, an entirely destroyed vineyard. It happens more frequently. Okay, now the title of the presentation is actually Early Leaf Removal, but again, before going into more details on that, I would like to throw this question. So is a human factor involved in summer pruning needs? Well, my very personal interpretation that yes, it is, because in some instances, actually, it is a grower himself that actually, maybe because he makes mistakes or he doesn't apply the correct practice, he runs into the need of summer pruning. And at least in Italy, in my area, this specific case is very frequent. In many instances, we do see new plantings that are established at a too narrow spacing in the row that would actually provoke over vigorous growth. And so you have too narrow in the row spacing so that you get extra shoots. But then extra shoots means that you have to do shoot thinning. But that also means that you have a lot of um, you have really a great need for repeated shoot trimming because you have to constrain your canopy size. And actually, at the very end, you also end up in having the need for leaf removal. So this is not exactly sustainable because if you sum up all the labor work that is needed to go through these different practices, it's really a lot. But again, my wonder is this really truly necessary, or should we do something to prevent, at least in part, this kind of scenario? And this comes the leaf removal operation. As you all know, the leaf removal can be mechanical or can be manual. Of course, this is a given leaf blocking machine working along a row, and this is how the row would actually look like after the machine run. Whereas in this case, you see such a clean canopy after the hand leaf removal. Uh, of course, if you use a machine, and this is another leaf blocking machine working on one side of a GDC trellis, of course, the machine is not perfect. The machine does not make a perfect job. And this picture would actually represent, on average, what we might expect after we have run a machine on a row where, of course, you have some leaves that have been stripped off, some other leaves have been broken, and a few leaves are still in place. But this is a typical outcome from a mechanical pruning operation. So it's always a partial leaf removal. Well, the other thing is, as I was mentioning before, what we would really need to understand if do we really need to leaf remove? Do we really need to de-leaf? So can we have any index or variable or something that can help us in understanding if a leaf removal is truly needed? Well, if we go through the literature, we do see a lot of papers that have been reported different indices for actually estimating the canopy density. It is fairly famous, referring to the old work by Richard Smart and others, where it is said that in order to have a balanced canopy, you should have 2-3 leaf layers in the canopy, and anytime the number of leaf layers would go above 3, 4, 5, 6, well, that is the case that maybe the leaf removal is needed. But what it's still a bit missing to me is, can we really associate numbers to this kind of criterion? And let me give you an example. The example is here. This is a trial that was published a few years ago, well, several years ago, I should say, where we were actually running whole canopy gas exchange measurements in the field. And we were actually working on single high wire Sangiovese canopies having, as you can see here, a very high leaf area. So we were starting with almost 13 square meters of leaf area, canopy area. And this is a total net photosynthesis on a whole canopy basis. And so what we did in that case, so we started from this point here, so we got maximum photosynthesis. And we were actually progressively de-leafing by removing leaves located in the inner part of the canopy. So we were actually removing shaded leaves. And so we kept removing shaded leaves up to removing 4 square meters of leaf area with no change in the total canopy photosynthesis. Then, of course, if you keep removing leaves at the given point, you go above the threshold beyond which you do see a decrease in canopy photosynthesis. But it is very important for this grower understanding that the optimum canopy density beyond which leaf removal is needed and below which leaf removal is probably not needed in that specific case was 6 square meters per meter a row. Well, finally, let's enter into the real topic. And the real topic is, again, early leaf removal. But this slide is very instructive to me because we have 5 different phenological stages here represented, going from pre-flowering until almost close to harvest. And so actually, we can also, in theory, apply leaf removal at any of these phenological stages. And the funny thing is that depending on the timing and, of course, the severity of our intervention, of course, we might be able to get very different results. And of course, today the focus would go into the early leaf removal. So we won't be talking about the traditional leaf removal, where for traditional leaf removal, we mean basically removing basal leaves anywhere between fruit set and pre-harvest to, give more air to the canopy to get better cluster exposures. Whereas early leaf removal is different. It has a different target. And we won't be able to talk about another interesting kind of leaf removal that is apical to the cluster late leaf removal. Will be next time, next Congress. So why early leaf removal? Well, the why is, first of all, the main purpose of an early leaf removal is not opening the canopy, is not actually giving more light to the clusters or, increasing ventilation. Of course, this is a sort of unavoidable effect. But the primary reason why we want to apply an early leaf removal is because we want to use a technique as a crop adjustment practice. Because other ways to adjust the crop are, winter pruning, shoot thinning, cluster thinning, well, other methods that have not been really applied extensively around the world. And so we thought, well, maybe early leaf removal can be useful to regulate the cropping level. And of course, this was not an idea of mine, not at all. Actually, usually in the vineyard, in many cases, we apply, maybe in a different way, very old principles. And actually, the inspiring paper was this one from the great Brian Coombe. And you see the date of publication. And he did this nice experiment. And the experiment was actually creating different defoliation treatments where, let's say, pre-bloom, he was actually removing an increasing number of leaves on a given shoot. And this is the outcome at the end of the season. Of course, the more leaves you remove, the lower would be the fruit set until, when you have only 2 leaves on the shoot, you basically have no fruit set because you don't have basically any source. Well, interestingly though, you see that this first row of clusters would actually respond this way. But if you look at the second row here, the bottom row, where the same treatments were applied, but at the same time the shoot tip was removed, you see that the situation is much better because even with only 2 leaves retained, there was a decent fruit set, but at the same time, the shoot tip was actually removed. And that is why we have this compensating effect. Removing the shoot tip would actually favor fruit set, whereas defoliating source leaves would actually lower fruit set. But you know, the idea was, why don't we try to use exactly the same principle by, try to calibrate the intensity of the operation to our purposes, okay? And, the ideal candidates for this kind of early leaf removal are those cultivars which have big clusters, heavy clusters, thick clusters. Okay, so we have here two excellent candidates. Barbera, that is the most important red variety that we grow in our area, as you have seen before. You see very compact cluster, okay, here. And Trebbiano, which is a Trebbiano Romagnolo cluster that is very famous for his susceptibility to bunch rot at that point. And so of course, then, the other thing was, you do have also cultivars that are more susceptible to botrytis, or maybe you grow varieties in an environment where the weather is more conducive to this kind of diseases. And this is probably the most important slide of my presentation, because this is basically how we apply the early leaf removal on our original work. So what we did, we were working on Trebbiano, as you will see in a minute. And what we did as initial treatment, well, as you will see in a minute, we were actually removing 8 basal leaves at pre-bloom. You see, that was a phenological stage when we did the treatments, and that was pre-bloom. There were just a few flowers open, okay? But what I want to really point out is, please start with not less than 6 leaves removed. Because, when you want to do this, but at the same time, you're not very convinced, and you want to be a bit conservative, you should, you think, well, maybe if I remove 3 or 4 leaves, that's enough. Well, that is not the case. We have run a number of studies, and many other colleagues have run a number of studies in terms of response of fruit set versus number of removed leaves. And believe me, you need to really provoke a sort of shock to the shoot in terms of photosynthesis if you want to have an effect. This is another detail that it is not a detail, because, you go out in the field, you are pre-flowering, and so you are removing, let's say, this leaf. This is a basal leaf that needs to be removed, all right? But at the same time, on the same node, you already have a developing lateral shoot. And so the question is, should I leave this, or should I remove this as well? I think that there is some debate on this, because it depends. It depends, for instance, on your environmental conditions. It depends on the weather pattern that you would expect after the leaf removal. I mean, if I am in a sort of, fairly warm environment, and I do expect hot spells in summer, very high temperature, I would actually maintain this one, because this is the way that some leaf cover can regrow around the clusters later on in the season. Whereas if you remove even this lateral shoot, you will end up until the end of the season with just a clean area here. And so you may run into sunburn issues. So please, try to consider the opportunity to maintain or remove depending on your environmental condition and on your enological purposes, of course. Please don't laugh, but the first time you apply the technique in a vineyard, after actually applying the technique, the row would look like this. and that seems to be a sort of naked row, but don't worry. I mean, this is perfectly normal. And if you go back to the same vineyard after a couple of weeks, 3 weeks, you will see a totally different scenario, because especially if you don't remove the lateral shoots, you might have a, a fairly good replacement of leaves around the basal part. So don't get scared. So when? Well, when, we already said that, it has to be early in the season, but it could be pre-flowering, it could be at flowering, or it could be also post-flowering. Do we have differences according to the timing, for instance? And the main answer is provided by this table that is taken from our, basically our original paper on early leaf removal that was published in the American Journal of Enology and Viticulture in 2006. And this are the data on Trebbiano, Romagnolo for 3 years. 3 years means non-defoliated, so the control with no defoliation. So defoliation pre-flowering, first is pre-flowering, removing 8 basal leaves. So it was a big shock. Defoliation post-flowering, removing the same 8 basal leaves, and then there was an intermediate treatment, removing 4 leaves pre-flowering and the remaining 4 leaves after flowering. So the total leaves removed during the season was always 8. Fruit set, what do you expect? Well, you do expect that the fruit set would decrease, and there was a really nice decrease. You see that the fruit set went down to 30% compared to 43% in the non-defoliated vines. And as a consequence, the cluster weight was much lower. You see that we have a big cluster, 400-gram cluster in the non-defoliated vines, and it was halved basically. And then, of course, berries per cluster would also go follow along. And, this was a bit disappointing, because, when you run this kind of study based on what we have said before in terms of, you would like to get a smaller, looser cluster that is less susceptible to rot. At that point, over a 3-year trial, you would hope having at least 1 wet year, so you can demonstrate that botrytis is better controlled. Well, that was a nightmare, because 203 was hot, 205 was hot, 204 was so and so, so there was really no botrytis around. But anyway, you do see that there was indeed, again, a significant effect in terms of reduced botrytis incidence. That is very interesting. But again, if I show you representative samples of the clusters from each treatment, well, this is a typical Trebbiano cluster. You see green or very packed. And these are samples from the leaf removal treatments, and these clusters, these two especially, are just great. Okay, you see that the morphology is totally changed. Well, actually, looking just at the color, you see that there is also an impression, well, it's not an impression, that, these clusters are more ripened than this one. And we need to explain why, of course. Believe me, but this fruiting area for Trebbiano is very unusual, very unusual. We are used to really big clusters, very compact clusters. This is, it really looks like a different cultivar. I think that, well, there is probably, oh, here we go. Well, the second part is, what about quality? And actually, I was discussing before, just looking at the color. Well, actually, Brix confirmed that, because you see that the Brix was 2 degrees higher on average than the non-defoliated treatment, okay? TA was fairly stable, even slightly higher in the defoliation treatment. pH was actually following this kind of differences very interesting that malic acid was slightly lower in the defoliated treatments, but that is fine because, of course, we have more sun exposure, but tartaric acid was actually increased. And that contributed to basically maintenance of a good total acidity. But the last column is very important. The last column is the, let's say, the sourcing balance. So it's a ratio between leaf area and yield that is given on a shoot basis. And apparently it is surprising that we had an increase in this ratio for the defoliation treatments as compared to the non-defoliated. And this seems a bit weird because, you know, the thought is, well, you removed leaves, how can you actually increase this ratio? But the leaf removal caused the more than proportional decrease of yield. And so when you calculate the leaf area to yield ratio, that would increase. And this is, to our interpretation, one of the main reasons why quality is also enhanced. Okay, so representative clusters, I jumped the slide, I'm sorry about that. And then at that point, there was really a new world ahead of us because we wanted to try other varieties. On Sangiovese is our most important red variety. We grow more than 70,000 hectares today of Sangiovese. We applied the technique by removing 6 leaves. And again, you see that there was a nice difference in terms of reduced fruit set. But here there was an additional issue that was very neat. And that you see that when we look at the berry weight, the berries were smaller in the defoliation treatment, but the amount of skin weight was the same. Well, that means that the relative skin weight was higher in the defoliation treatment, and this probably contributed to higher color. And higher color for Sangiovese is so important. And skip this probably because I really want to comment on this. It was nice actually seeing that other people got interested in the technique. This is really a brilliant paper published from my friend Brian Head from Penn State. They did a tremendous trial lasting for 5 years in a wet environment, right? Where they were comparing, you know, different early leaf removal by hand, by machine, versus, no leaf removal. And in all cases, the control treatment was basically 2 sprays at pea size and variation. And you see that regardless of the season, you know, when they applied hand trace bloom leaf removal, you know, the result in terms of reduced botrytis was really very good. Of course, with relative differences changing from year to year, but it was fairly constant over different seasons. This is just one thing. I'm sorry, the graph is still in Italian, but when people ask, what about actually the risk of sunburn, berry sunburn, when you do this so early? Okay, if you look at this panel here, this is writing is a fraction of clusters with sunburn damage. And you see that when you apply leaf removal at bloom or fruit set or veraison, so the later the operation and the higher is sunburn damage. But that is fairly understandable for a number of reasons. It's a long-term adjustment, for instance, to this canopy opening. And also keep in mind that when we apply the leaf removal, the early leaf removal in Italy is basically the last week of May, when the ambient temperature is around 20 degrees. And so it's not 35 degrees. That is another good reason. So it's too bad that we are not sitting all together in a Congress hall, but they would be the nice question. So what is at this point the canopy that has been treated with early leaf removal? Well, of course, is this one on your right, because you see that after the pre-flowering leaf removal, some leaf cover has been produced from lateral shoots. And so here we have a sort of intermediate light macroclimate that is something that we like a lot in a warm environment. How? Well, the how goes into the second question that a grower would actually throw at this point. And the second question would be, should I do this by hand? I have 20 hectares, I can't. And so that was the idea of, can we try to mechanize this operation? Although it has to be done, let's say, pre-flowering. And so again, general picture showing a number of different leaf plucking machines. Actually, here we have two different principles. These are actually leaf plucking machines. This one, a leaf air pressure machine. And what we would like to achieve when we say we use a machine for leaf removal is exactly what you do see here. So the machine is actually able to remove the blade of the leaf without damaging the inflorescences. Because, if we say, okay, it worked, but then at the end of the day, you verify that it worked because I cut all the clusters in two halves, that doesn't count. You don't really want to touch the clusters, right? And anyone has his own ideas, but for us, the better performing machine was this kind of machine. As a Collard type, it's an air pressure machine, and the reason is exactly this one. If you want to use this machine, our experience would say that you need to use the machine not after this stage. So basically, all the flowers should be closed. Maybe you can tolerate having just a few open flowers, but no more than that. Because if the cluster is like this, when you blow air at very high pressure, the air goes through the cluster, and it would actually it would not damage the cluster, whereas when the air hits the leaf, that is a compact tissue, that the leaf should be blown away. Just an image of the machine working along a row. And a question that I would have liked to throw now to the audience would be, okay, this is a row of Lambrusco, okay, in the Po Valley that has been treated mechanically. Would you be happy of this kind of result? Do you think that the machine was able to remove enough leaves to cause that source limitation that is very much needed to achieve our yield regulation effect? Well, I would be very happy if I had this kind of result, because when you go and try to estimate the amount of leaf area that has been removed over the first 6, 7, 8 nodes, in this case, that would be more than 70, 75%. That it's a lot. And so you should be very happy about this. But it was really unbelievable. When we tried the machine in Spain, this is a trial that we had with my friend Xavier Tardáguila from La Rioja in Spain. We still remember the kind of soil that was not really easy thing to step in. And you see here, there was a leaf removal, early leaf removal that was made with the same machine. This is Grenache. And you really see, in that case, we measured up to 90% leaf removal. So that means that you have the perfect machine with the perfect driver working at the perfect timing, okay? But again, we need numbers. We do research. And so we need to, convince people that we are telling the truth by also showing numbers. And so we did, to test the effectiveness of the mechanical leaf removal, we did a 3-year trial, of course, on Sangiovese in Italy. That's been published again a few years ago in the Australian Journal. Non-defoliation, this MA is for manual. ME is for mechanical. We did that pre-flowering, post-flowering, and just for being very quick in commenting the results, you see that, of course, the machine treatments were not as effective as the hand treatments, but there was a significant decrease in the yield per shoot, in the cluster weight. There was no effects on berry weight. There was a significant decrease in thickness. And again, same issues. The seasons were not actually wet enough to, let's say, have a significant botrytis damage. So again, the machine can be used. You need to be careful because you need to use, again, the proper machine, the machine that you know, well, please try. It can be done. But again, the grower comes up again and he asks another question. And the question is, Professor, okay, you have demonstrated that it works by hand, it works by machine, but I don't have time to do that by hand. And I don't want to buy a machine for that. I don't have the money. And so do we have any other option for trying to get this source limitation without being able to use either hands or a machine? Well, I mean that we have two alternatives. One alternative would be shading. Okay, instead of removing, or we just shade the leaves. But you know, shading means that you have to use, for instance, shading nets. And the shading nets need to be set up. They have to be removed. It's not easy. And so we thought maybe another option that is really non-invasive, is really sort of neutral, is using something that is well known as an anti-transpirant compound. I mean, we have on the market anti-transpirant compounds that are actually able, once they are sprayed on the canopy, they quickly evaporate, and they actually leave on the leaves a thin, transparent film that would actually, you know, shut down a little bit the gas exchange, and they would reduce either transpiration and photosynthesis. VaporGuard is the compound that we used. The active ingredient is a pinolene, that is a substance that is extracted by the pine tree. And you know, it is amazing because when you once you spray the chemical on the canopy, in a couple of hours, the chemical evaporates. And after that, you know, the canopy looks very glossy here, you see, very lucent, very typical. Okay, so we did this work in 2010. And well, of these different panels on the left side of this slide, you should take a look at the second one, this one, where we have the seasonal values for leaf photosynthesis, okay? And you see that upon first spraying and second spraying, the chemical was actually able to decrease photosynthesis, as we expected, of course, by approximately 50% versus the non-sprayed control. And it was nice noticing that this sort of limitation went on for approximately 40 days. And then the chemical was probably washed off. But it was nice also seeing that the previously sprayed leaves were actually able to recover up to the levels of the non-sprayed leaves. So in other words, this is a sort of partial early leaf removal because you sprayed the chemical exactly at pre-bloom. And, you know, the source limitation is not as high as the one you get by eliminating the leaves, but it lasts longer. And at that point, the question was, is this source limitation high enough to get the desirable effect that we want to achieve? Well, of course, I throw a question, but I already know the answer. And in this table, there is a summary of the data that we published on the Australian Journal. Again, a 3-year trial on Sangiovese where we were comparing sprayed versus control vines, non-sprayed vines for 3 years. And again, if you look at the column with the significance, you see that basically, yield per vine was lowered by the anti-transpirant treatment every year. There was a lowering of berry weight that was really interesting. So we were able to get always smaller berries. And there was also a sort of expected improvement in soluble solids, in phenolics, in anthocyanins, exactly as we basically saw on Sangiovese and on Barbera. Okay, keeping an eye on my time, I think I still have 5 minutes, and that makes me very happy because I think I'm really have in a good shape with the time. Advantages of this approach. Well, there are many advantages. Well, first of all, it's fast and there is no chance that you can damage the clusters. You're just spraying. High flexibility, because it is true that you don't remove anything, but depending on your target area and depending on the concentration, by the way, we were using here a 2% concentration. I mean, adjusting these two factors, you can actually get a higher or a lower effect. Nice knowing that after the chemical goes out or it is washed off, I would say, the leaf does not get damaged and it is able to recover. Oh, this is very important. The big difference is that using this kind of approach, what we do is that we get a source limitation, but at the same time, the macroclimate is not changed around the clusters because we are not removing anything. And so at that point, you may want to consider that this might be quite nice if you work on a given environment. And then, I have turned 60 this year. Well, last year actually. And so I have been working in viticulture for 35 years, almost 40. And as long as I go on, I understand that psychology is very important in viticulture, because if you go there and if you tell the grower, hey, what you need to do is just mix this chemical with, let's say, your pest and treatment and the same tank, and you need to spray, well, he's gonna do this. And so again, psychology is really important. I'm concluding with 2 more slides. The technique has been trialed in many countries. This is a very recent paper that has been published in Frontiers by that guy who has a name that I don't want to read. Other co-authors, Professor Sabatini from Michigan State, for instance, and those dots would represent locations where the technique has been tried. And, this meta-analysis that is reported in this paper would actually explain that some of the effects are very consistent across a number of different conditions. So reduced bunch rot severity, incidence, reduced yield. So it is confirmed that is a good tool for regulating yield, reduced cluster compactness. Whereas on the other side, you would say that basically all the quality parameters would increase, significant increase in breaks. I should say that in our trials, color has always improved a lot. The meta-analysis here does not reach significance, but I would be optimistic, especially in certain environments, to be able to largely increase the total anthocyanins concentration. And I think I can close here. Thank you very much for your attention. And of course, I'm available for any question. Well, thank you for listening.
Dr. Patty Skinkis almost requires no introduction. She is well known in the Oregon wine grape growing community and is a critical resource for growers up and down the state. She conducts applied research at Oregon State University and provides outreach and educational programs for the industry. Dr. Skinkis' research program focuses on applied viticulture and whole plant physiology studies designed to understand causes and management of vine balance and impacts on fruit composition and wine quality. As an extension specialist, Patty develops educational programs and informational publications for the industry statewide. She plays a critical role in bringing industry members together in technical groups to foster information exchange between the university and industry. She also teaches undergraduate and graduate level viticultural courses at OSU. Her efforts expand beyond Oregon as she is a member of the National Clean Plant Network Grape Advisory Board, is an associate editor for the American Journal of Enology and Viticulture and Catalyst Journal, and is president of the American Society for Enology and Viticulture. She'll be speaking with us today about some of her experiences and trials with leaf pulling here in Oregon. It's always a pleasure to hear from Patty, and especially to hear what's going on with research right here in our vineyards.
All right, well, thank you for this opportunity to present some research from right here in Oregon. It's nice to follow Dr. Pony after he presented some excellent work that has been done over in Italy and in Spain, and bringing it back home here to some work that has been done in Oregon. So why we remove leaves specifically in Oregon, as a general practice, we do it to increase spray coverage for our pesticides, primarily for powdery mildew and botrytis control. Also labor efficiency. We find that many of our labor crews are much more willing to go and work in leaf pulled vineyards because it's easier to thin out fruit at leg phase, as well as harvest fruit by the time we get to the harvest season. Also, we found benefits for both fruit and wine composition. Now, much of Western Oregon has pretty high vigor canopies, high vigorous sites where leaf removal is definitely warranted. Some of this has to do with the reasons that Dr. Pony indicated early on in his presentation about having really tight row spacings or in-row spacings, which lead to some really high vigor. And of course, our climate, both in northern Willamette Valley, southern Willamette Valley, and into parts of southern Oregon as well. So we have quite a bit of soil moisture leading to highly vigorous vines. The best management practices for leaf removal, typically we're removing those leaves right in that cluster zone. Oftentimes it's morning sun side only to prevent sunburn on the late afternoon sun. Producers may remove between 50 and 100% of the cluster zone leaves. And it's, of course, as I mentioned before, best in those high vigor, high density canopies. The timing is between bloom to fruit set. We've identified that as being optimum for Oregon based on studies that I'll show you in a few minutes. Of course, the latest we would recommend leaf removal being done is at pea size to bunch closure. We do not recommend that you start doing, I want to emphasize that, at veraison or later because it can lead to substantial sunburn. So I'm going to start out talking about determining the optimum timing of leaf removal practices in Oregon. These studies were done over a 4-year period initially across a number of different vineyards, but I'm going to focus on the later years of the trial. What we did was we did 100% cluster zone leaf removal at 5 different stages, or I should say 4 different stages, from pre-bloom when the berries or the flowers are just beginning to separate. Bloom, where if we had about 50% cap fall, was our second time point, the BB to pea size stage, and then bunch closure was our latest time point. So starting at those time points, we were removing between 5 and 7 leaves from the cluster zone by hand. And we compared those to no leaves being pulled. This was done in Pinot Noir in 2 different vineyards, both of which were using organic management practices. They weren't necessarily certified organic. The goal was that we were trying to expose the clusters early to be able to improve our botrytis and powdery mildew control, but also have some benefit for fruit quality. So here's an example of our earliest stage when we did the pre-bloom leaf removal. This is very similar to the pictures that Dr. Pony had shown with that early pre-bloom leaf removal with 5 to 7 leaves being removed. It's quite drastic. The shoots aren't very long at that stage. We would have pulled off between 5 and 7. We weren't going as strict as the 8 that he had mentioned. So we were looking at whether this could also control the amount of crop that we had on the vines. And what we found was the earliest leaf removal did reduce fruit set by 20% in the 2 years where we did this at 2 commercial sites. It was very interesting that it was the same amount of fruit set reduction, but by the time we got to measure whole vine yields at the end of the growing season, it really didn't influence the overall yield. This is probably due also to part of the thinning practices commonly being done, but this was also done in some cool years in 2011 and 2010, 2 of our coolest years in recent history. That also would have been a major concern about not having enough carbohydrates to the flowers during a time when we had cool and cloudy bloom time. So we did have some reduction in fruit set. Our cluster sizes were smaller. We did quantify the impact on botrytis. And what we found was that if we did any leaf removal, whether it was done pre-bloom or later during the season up to bunch closure, we did reduce the amount of botrytis. So on the left-hand side here, you can see the no pull. So these vineyards, they allowed us to not pull any leaves and compare that to any of those time points from pre-bloom to bunch closure. And basically we significantly reduced the amount of botrytis in those berries and clusters in both of the vineyards, whether it was the warm early site or the cooler late site. And the 2 different bars here just mean the incubation of the clusters pre and post, the amount of botrytis pre or post incubation in the lab. But it wasn't just that we helped reduce the amount of botrytis in those commercial vineyards, but we also had an increase in anthocyanin. For Pinot Noir, that's really important, especially in some cool years. So we did see that bloom time leaf removal increased the anthocyanin, total anthocyanin across the 5 different groups as well compared to the control. So it did definitely influence the quality and the disease control. After we did these studies, a lot of people started using these practices, doing early season leaf removal in the years that followed. So the 2011, 2012, 2013, we've really looked at the canopies and we see a lot of vigor. Here's an example of a pre-bloom leaf removal. It was done on a larger scale in a commercial vineyard. We have sufficient canopy growth. There's a lot of vigor in overall in that canopy. It's pretty high density vineyard, and leaf removal was done by hand labor crews. Of course, when the labor crews came through to pull those initial leaves, laterals would either have to be pulled right away or they would have to be coming through to remove those again. In our initial studies, we removed the leaves initially and then the laterals grew and we later pulled those so that we would have a completely clean canopy. Here's another example of commercial adoption in a cordon-trained spur-pruned Pinot Noir vineyard. And you can see that there's plenty of shading still in the upper canopy, and it's just removing those leaves to be able to get better airflow in that really high density vineyard. So we did those trials early on in years that some people would argue were our cool years, and more recently we've become a lot warmer in our summers, and that's certainly true. And so we did another level of leaf removal trial in 2018 and 2019. And the goal of this study was to see if we could mechanize this and actually improve color in a red blotch vineyard, a vineyard that had 100% red blotch. And we know that Pinot Noir with red blotch tends to have less color. So we did hand pre-bloom leaf removal, 100% of the cluster zone being pulled, and compared that to mechanical leaf removal at fruit set. And so these vines actually show what the canopies look like after leaf removal was done and about the pea-size stage or close to bunch closure stage. So you can see the hand pre-bloom leaf removal had a much cleaner cluster zone compared to the one that had the east side only mechanical leaf pulling. But we did see some great results. The pre-bloom leaf removal did not lead to any sunburn. You can see here's the fruit at harvest in 2018, which was a very warm, very dry season for us. This is a closer picture of that fruit. It's really beautiful. We did not have as dense of clusters that year due to that pre-bloom leafing. We did have fewer berries per cluster and slightly smaller berries. We did see an increase in anthocyanin, although it's not statistically significant in the figure here. We do see a general increase. And we did see that when the wine was produced from this study, both on a commercial scale, but also on our small lot scale, we did have increased wine color intensity with the pre-bloom leaf removal. We had greater total phenolics and greater aroma compounds as well. So those are just a brief review of some of the studies on the timing of leaf removal. Now I want to talk a little bit about intensity, because those prior trials were done with 100% leaf removal in the cluster zone. So over this trial years, we looked at 0, 50%, 100% leaf removal in the cluster zone, and what we call the industry standard, which is just removing east side leaves only. The 50% leaf removal was every other leaf along the cluster zone was removed per shoot. And then 100%, of course, was all leaves within the cluster zone removed. So about 5 to 7 leaves in the 100% range, about 2 to 3 leaves in the 50% range. And what we found in this study, when we did it in 2 commercial vineyards over three seasons, was that we had a greater impact in our high density vigor vineyards. So high vigor, high density, we were able to reduce the canopy more by leaf removal and increase our sunlight exposure with that leaf removal at the 100% range. And the moderate vigor had much less of an impact, just because it didn't need to have, its shading wasn't as intense as the other 2 years. We did find a 21 to 45% lower sunlight exposure in our no leaf removal treatments. And that sunlight exposure definitely had an impact on fruit composition. So the most notable effect, which was very interesting, that we noted in the fruit, and this is from the fruit itself, not the wines, we found that with increasing leaf removal, we have more sunlight exposure, more sunlight quantified in that cluster zone, and an increased amount of beta-damascenone, which is one of the aroma compounds that is most important for quality identity for Pinot Noir. It's a blackberry aroma, a fruity aroma. We found that to increase significantly with leaf removal. We found that it had less of an impact in our cooler year, our 2011, and then in the year where we had a less vigorous vineyard that we used in 2012. So it had a greater impact in the year where we had a very cool season and high vigor vineyards. So applying your leaf removal practices differently by season may also be a benefit. We did not find any impact of our fruit composition for the leaf removal trials on basic ripeness, so Brix, pH, or TA. We did not find total anthocyanin, total tannin, or phenolics in our intensity study, which was quite interesting. Leaf removal did increase quercetin, which is a phenolic that's often increased when we have sunlight exposure. Anthocyanins, pituitinin, and malvidin specifically did increase, although we did not have a total anthocyanin increase. And of course, beta-damascenone, which is that important aroma compound, which we think might have to do with carotenoids being developed as photoprotectants that then are broken down into beta-damascenone. So the take-home message from the various trials in Oregon is, do not fear leaf removal. It can be quite a beneficial management tactic, especially for our vineyards that tend to be highly vigorous and high density and big canopy leaves. The timing for us has been the earlier the better for both disease management standpoint as well as fruit quality. And invariably, we have late season leaf removal leading to sunburn, and that's when it's starting late season rather than doing more leaf removal in addition to earlier leaf removal at that time. And it really is a necessity for a lot of our vineyards that want to go organic or biodynamic. Having that as a tool in itself, even when we don't have effective botryticides, is really critical for disease management. So that's all I have for my summary here in Oregon, and I'll be online to answer questions that you may have about the studies done here. Thank you.